A developer just revealed that they accidentally logged phone calls being routed to military bases. Not by hacking a phone network. Not by tapping a wire. By registering a DNS zone. Here's how the phone system's hidden dependency on the internet made this possible. To understand what happened, you need to know about a system most people have never heard of, E.164 ARPA. When you dial a phone number, that number needs to be translated into a route, a destination on the network. The international standard for phone numbers is called E.164. It's what gives us country codes, area codes, and subscriber numbers. But modern telecom infrastructure often needs to convert these numbers into internet-routable addresses. That's where ENUM comes in, E.164 number mapping. It uses DNS, the same domain name system that translates website addresses, to map phone numbers into URIs. And it does this through a special domain delegated by IANA, E.164 ARPA. So when certain systems need to route a call, they send a DNS query to this domain, essentially asking, where does this phone number live on the network? According to a blog post published today by a developer going by Lena, they gained control of a delegated zone within the E164 ARPA namespace. The exact mechanism is detailed in their post titled Hijacking E.164 ARPA. Once they controlled that zone, DNS queries started arriving, resolution requests for phone numbers. And among those queries were lookups for numbers belonging to military installations. They weren't intercepting the audio of phone calls. They were seeing the metadata, the fact that a call was being routed, to which number, and when. But even metadata at this level is sensitive. Knowing when and how often calls are placed to specific military bases reveals patterns of activity. The developer states this was entirely accidental. They were exploring the DNS infrastructure, not targeting military communications. Here's why this works technically. The E164 ARPA domain is hierarchically delegated, just like regular DNS. Different organizations are responsible for different portions of the number space. If delegation records are misconfigured, abandoned, or if a zone can be claimed through legitimate registration processes, someone can become the authoritative nameserver for a block of phone numbers. Every DNS query to that zone then passes through their servers. They see the query, the phone number being looked up, in their logs. Now, not all phone systems use ENUM for every call. Traditional circuit switched networks don't. But VoIP systems, SIP trunks, and modern telecom infrastructure increasingly rely on DNS-based number resolution. That means portions of military and government phone infrastructure may route through these DNS lookups without anyone realizing the resolution path has been compromised. This matters for three reasons. First, it reveals that critical telecommunications infrastructure has hidden dependencies on DNS, a system designed for website addresses, not national security. Second, the metadata exposed, call timing, frequency, and destination, is classified as sensitive intelligence in most military frameworks. Even without hearing a single word, you can learn a lot from knowing when a base is receiving unusual call volume. Third, and perhaps most importantly, if a developer stumbled into this accidentally, it raises the question of whether state-level actors have been exploiting this same mechanism intentionally. The E164 ARPA system has existed for over 2 decades, and DNS delegation vulnerabilities are well understood in the security community. The developer published their findings as a blog post, which is now trending on Hacker News with significant community discussion. Responsible disclosure of DNS infrastructure vulnerabilities typically involves coordination with the relevant registry operators and affected organizations. The broader implication is that telecom regulators and military infrastructure teams may need to audit their ENUM delegation chains, verifying that every zone in the resolution path for sensitive numbers is controlled by a trusted party. This is the kind of vulnerability that isn't a software bug you can patch. It's an architectural assumption that needs to be re-examined. The internet was built on trust and delegation. Every layer of infrastructure assumes the layer below it is honest. When those assumptions break, even accidentally, the consequences can reach places nobody expected, including military bases. Link to the full technical write-up is in the description. Subscribe if you want more stories about the hidden systems that run our world.